All right, if you look at this question, we are asked to calculate, we are given this diagram, which is question 5. I posted on the group, then we are asked to calculate the work net. So the first thing you do is this, you check which of the method that will work for you. Remember the very first one, the work energy theorem is equals to change in kinetic energy. In order to calculate the kinetic energy, I need the initial velocity, I need the final velocity. I know the initial velocity to be 0, but the final velocity is unknown. So if you look at this, you will see I need to calculate this, but I didn't know this. Although I can calculate it from there, but that would take me a longer process. So I try another method. I will say the work net is equals to the sum of all the work done by all the forces. In other words, work done by normal force plus work done by frictional force plus work done by gravitational force. And if you look at in this instance, you will see that we are given the frictional force and we are given all the information to calculate the work done by gravity. So this is an easiest route for us to follow in this example. So from here, the work done by the normal force is always 0 because the force is always perpendicular to the surface. Then come to the work done by this, work done by the frictional force, displacement, cos of theta, where theta is the angle between the displacement and the frictional force, plus work done by the frictional force, displacement, cos theta. So if we do the substitution, you can see that this one is 0. Here we are given to be 150 and multiplied by the displacement 135 times cos 180. This one is always 180, the first or the work done by the, I'm calculating the work done by the frictional force. The angle here is always 180 degrees. Plus, let's calculate the work done by this. We said mg 70 times 9,8, which is mg, times 135 times, if you look at it here, you will see that the direction of the displacement is downwards. So anytime you have that the direction is downwards, the easiest thing is to say 90 minus the angle of inclination, which is 25. And if you look at this question, you will see there are also many other ways in which I will calculate the work done by the force of gravity. I will come to that. I'm just using one method here. After this video, I will also show another method, so you choose the one we prefer. So if you punch everything in the calculator, you will see we still have 0 plus, because of cos 180 is minus 1, we're going to get negative 0.250. This is the work done by the frictional force plus then the work done by the gravitational force, 9138,677. So if we add everything up, we'll get the number of the work done by the next force to be 18,888,677. And remember, joules, remember to put the unit. Remember, we have to leave our answer to the minimum of 2 decimal places. And also, I can also calculate, remember, just like I said, I can also calculate the work done by I can also use FG parallel, don't be confused. The work done by FG parallel, I can also use that one. If I'm using that, I'm going to have the FG parallel times the displacement cos theta. FG parallel, is mg sin theta displacement cos theta. So if I substitute here, you see I get 79.8. Remember that this sine is sine 25 times 135 times cos. If we get here, remember that this one is going down and the displacement is down, so the angle between them is 0. If I do that, I'm still going to get the same answer, 39138,677 joules. So you choose whichever method you prefer. Choose whichever method you prefer. And one thing you should not do, you cannot use two of them at the same time, because this is the real force, the force of gravity, which is moving downwards. The FG parallel is its component.